Okay, Walkers, today we're looking at journal page 14, graphing absolute value inequalities. Okay, so the first one we have y is less than the absolute value of x. Now, if there's no line underneath, it's a dashed line, and if it's less than, you shade below. Now, this says y less than or equal to absolute value of x. Now, if there's a line underneath, it's a solid line. Since it's less than, we shade below. You would update that. All right, now let's take a look at y is greater than absolute value of x. Again, if there's no line underneath, it's a dashed line. Since it's greater than, you shade above. And then you have y is greater than or equal to the absolute value of x. If there's a line underneath, it's a solid line. Since it's greater than, you shade above. If you would update your notes. Okay, now your notes are updated. Let's take a look at the examples. Okay, graphing absolute value inequality functions. Okay, graph the absolute value inequality. Again, we're going to graph by direction. Now, we know that the parent function's vertex starts at 0, 0. That plus 4 means we move the vertex left 1, 2, 3, 4. Okay, now we know the directions for the absolute value are negative 2, 2, negative 1, 1, HK, because we move the vertex 1, 1, 2, 2. Now, this tells us which direction we go. From the vertex, we go left 2, up 2. Left 1, up 1. I'm sorry to say right 1, up 1, right 2, up 2. Left 1, up 1. Left 2, up 2. And we know it makes a V, so we can extend all those points to the end of the graph. And you want to do that because it makes making the dashed line easier, and we know it's a dashed line because there's no line underneath. And so if you connect every other point, you have a very easy way to graph your dashed line. Okay, now since it's less than, we shade below. And you actually want to shade outside of the graph because mathematically the shades actually extend past what's on the grid. Okay. All right, finish up example 1. All right, example 2. Now it looks like the vertex is going to be transformed up 4 units. So the parent function was at 0, 0. Now we go up 1, 2, 3, 4. There's your new vertex. And we graph by direction. Real simple. We know the directions for absolute value are negative 2, 2, negative 1, 1, HK, because the vertex moved. 1, 1, 2, 2. So we go right 1, up 1, right 2, up 2, left 1, up 1, left 2, up 2. And we know we can extend those, complete the V shape of the absolute value. And to get that, you would just go left 1, up 1, left 2, up 2, left 3, up 3, left 4, up 4, left 5, up 5, left 6, up 6, left 7, up 7, left, or I'm sorry, right 8, up 8, right 9, up 9, left 1, up 1, left 2, up 2, left 3, up 3, and so on. I'm not going to do that in every problem. Just know that that's how you get the V shape. All right. Again, now there's no line underneath, so we know it's a dashed line. And it's greater than, so we know we shade above. Okay, go ahead and finish up example 2. All right, now let's take a look at example 3. All right, now it looks like we move the vertex right 4, 1, 2, 3, 4, up 1. Okay, now we're going to graph by direction, which we know is -2, 2, -1, 1, HK, because the vertex moved, 1, 1, 2, 2. So we go left 2, up 2, left 1, up 1, right 1, up 1, right 2, up 2. And then you go right 3, up 3, right 4, up 4, right 5, up 5, right 6, up 6, and then so on up. And then left 3, up 3, left 3, or 4, up 4, and so on. Okay, there's a line underneath, so we know it's a solid line. And it's less than, so we shade below. Okay, go and finish up example 3. All right, let's look at example 4. Okay, now first off, we move the vertex. It looks like left 4, down 1. So left 1, 2, 3, 4, down 1. Okay, and we graph by direction. Okay, now we know that it's -2, 2, -1, 1, H, K, 1, 1, 2, 2. Now, what's unique about this is that we have to multiply the y direction by -1 because of the negative right there. So that's -2, -1, -1, -2. Okay, so from here, from the vertex, we go left 2, down 2. Left 1, down 1, right 1, down 1, right 2, down 2, and so on. Okay, there's a line underneath, so we know it's a solid line. And it is greater than, so we shade above. Okay, go and finish up example 4. All right, let's take a look at example 5. Okay, now it appears the vertex moves right 4 units, so 1, 2, 1, 2, 3, 4. Now we're going to graph by direction, but I'm going to pick specific points because I know that I'm going to have to divide by 3. Okay, I'm going to pick numbers in increments of 3 so that I can divide by 3. So I'm going to do -6, 6, -3, 3, H, K, 3, 3, 6, 6. The reason why I picked those values is because I know that I can divide them by 3. And that's what we have to do with the y directions now. Divide by 3. So that is 2, 1, 1, 2. So those divided by 3 is a little hard to read, so I'm going to try to clean that up a little bit. All So now our new directions are we go left 1, 2, 3, 4, 5, 6, up 2, left 1, 2, 3, up 1, right 1, 2, 3, up 1, right 1, 2, 3, 4, 5, 6, up 2. There's no line underneath, so it's a dashed line. All right, and it's less than, so we shade below. Technically, we should shade here, but I'm going to use that space for example 6, okay? All right, now example 6, we need to move the vertex. So we go left 1, 2, 3, 4, up 1. Okay, that's a new vertex. Now we're going to graph by direction, okay? So our directions are -2, 2, -1, 1, HK, 1, 1, 2, 2. But we have to multiply the y directions by -2. So that is -4, that is -2, that's -2, and -4. Kind of stole some space from the graph. All right, so from here, we go left 2, 1, 2, down 1, 2, 3, 4. Left 1, down 1, 2. Right 1, down 2. Right 2, down 1, 2, 3, 4. We know that there's a line underneath, so it's a solid line. And since it's greater than, we shade above. Okay, so go ahead and finish up example 6 and start working on your assignment and have a wonderful Wildcat day.